Welcome everyone to a new IoT tutorial, and in this tutorial we are creating power monitoring system using Node MCU. So in this tutorial I am going to use the ESP8266 Wi-Fi module and this ACS712 current sensor module, and using these we are going to measure the current and power, and we are going to send these data to Adafruit.io IoT platform. So for that we are going to use the MQTT protocol for sending these data to the IoT platform. So let's get to the demo. So now you can see in the bottom right side we have our hardware setup where the current, this is the light bulb, and it is in currently off state. Okay, and currently we can see the current rating is 0.06, which is coming from this Node MCU to this Adafruit.io platform. But we can see that this light bulb is in off state. Still this is the rating, because this is one disadvantage of ACS712 sensor, that we need to calibrate it. We need to set some threshold, like I need to subtract this value for getting the zero value of current at when it is in off state. So we can say that it is 0.09 or 1 some percentage of error we have here. So similar to that, we are also getting this error power of 13. Right now it is in off state, but we can calculate the exact power when we turn on this light bulb, and we will see the change. By noticing the change, we can subtract the value and get the real data. Okay, so let me turn on this light bulb. Okay, so if I can see 0.06 to 0.17 ampere RMS. Okay, and 13 to 36. So we can see there is a change. Let me see. Okay, so 36, 13, 36, 31. Okay, so there is a change of values. You can see there is a change in also the power rating, which is in watt, and also the current rating, and we can see the same value change. If you can see 0.17, and there is a 6 second of delay between the ratings. Okay, so if you can see this line chart, we have 821, 823, okay, 25, 27. Okay, there is less delay. So if I will hover over it, you can see the difference between the second delays. Okay, so this is the chart is showing the data of power rating basically. Okay, and the second current is showing this gauge is showing the current. Fine. So these are the two charts, two widgets which I have used from Adafruit.io, and we will explain all other things, all the other parts, like how this MQTT works here, in the next part of this tutorial. Okay, so for this video is divided into 5 parts. We have already seen the demo of this project. Now we are going to see the project explanation. I will explain what is this project all about, and then we will see the circuit diagram, the architecture of this project, and at last we will see the code. So for this project we are coding in Arduino IDE. Okay, so that is the code editor which we are using here. So going to the next slide, these are the requirements for this project. This is the first requirement, which is a Node MCU ESP8266. Okay, and since we are going to use this, because we need to connect to a broker, MQTT broker, which is in cloud, so we need the internet connection, and for that we need a Wi-Fi module. Fine. And the second requirement is ACS712 current sensor. Fine. So this is the current sensor which we are using to measure the current, and this sensor, talking about this sensor uses Hall effect. Fine. So for detecting this current. Okay, and the third requirement is a light bulb or any kind of load. Okay, so in this project I am using the light bulb, and you can also use any load. So we will talk about current sensor, a few more points about current sensor here, that we have few variants of this current sensor ACS712. The first variant is 5 ampere, which can measure up to 5 ampere. The second variant is which can measure up to 20 ampere, and third one is 30 ampere. Fine. So according to your load and how much current you want to measure, you will choose this ACS712 accordingly, and the code will also change according to this according to your choice of this current sensor. Fine. So these are the requirements for this project. So next slide is the circuit diagram, and we can see we have this Node MCU. and this is the analog pin A0, which is the only analog pin of node MCU. And we are using this is, since this is an analog sensor, we are using this A0 pin to read these read this value. They read this value from the sensor, and which will basically indirectly interpret the current reading. Okay, so using the that we will check the current, how much current is this load is taking. Fine. And this is the power source. Power source is a 240 volt AC power supply. Okay, so you can see the ground is connected to the ground of this node MC. You can see the 3.3 volt is connected to the 5 volt pin of this ACS712. But in actual scenario, our node MCU, some node MCU can't supply 5 volt, so you need to make it external 5 volt, or because the sensor will not work properly if you don't provide 5 volt to this sensor. Although you can try to put V in pin, which is this pin. If it is not used anywhere, where, then you can use this V in pin to power this module, and this V in pin can easily provide 5 volt if you power supply this node MCU using a USB cable. Okay, so these are the things to make the sensor work. And at the second, at the another end, we can see we have this these are the two pins we have. One pin is directly connected to the light bulb, and the second pin is connected to the positive rail of the power supply, 240 volt AC power supply. And this negative volt of this AC power supply is connected to the light bulb negative terminal. Okay, so this is the circuit diagram. We have used this same circuit diagram in the project. Okay, so now we can move to the architecture section. Okay, and parallelly we can also see the code, so that our understanding will be clear. So let me see. Okay, so here is the architecture for this project, and we can see in the code. Let me explain the code from the starting, so that we can go through the architecture in a similar fashion. Fine. So we are using MQTT here. Okay, so the MQTT broker which we are using here is the Adafruit.io MQTT broker. Fine. So Adafruit.io is a IoT platform which is basically provides us various interfaces to send data to their platform, and there we can visualize data through different kind of widgets. Fine. So we have interfaces like HTTP or MQTT. So here from device, the best protocol to send data to any kind of IoT platform is basically MQTT. So it is very lightweight protocol, and so we are using MQTT in this project. Okay, so Adafruit.io supports MQTT, and you can see the documentation for that. But what I have done is I have used this MQTT.h library. Okay, so I will provide the link of this library in the description of this video. Fine. So using this library, I am sending this data via MQTT to Adafruit.io. Okay, so if we can see the architecture, the Adafruit.io MQTT broker, we have the topics. So we are directly from the node MCU, we are sending the data to these two topics. This is Jignesh K5, which is the username. Okay, so the topic structure in Adafruit.io is username slash feeds slash this is the name. Okay, so what is name? Name is basically a new dashboard. Okay, so there is already existing dashboard, but if let me create a one dashboard. Let name it test. Okay, so create. So we have created test dashboard. So after that we can, when we are adding a new block or a widget, let's say we are adding a gauge. Okay, so you can see the first option is selecting a feed. So this feed is basically the MQTT topic. Okay, so either you can create the feed and then configure the same in your Arduino code. Okay, or you don't need to create anything here. Simply create set these topics like this. You can see power, current, voltage like this, and you can simply send the data. Fine. And this topic which means the feed will be created automatically in this list. Okay, so this is how it works. So we have already the feeds which we have created. Fine. So let me try to create a new feed here, so that we can test this in real scenario, like in this test dashboard which I have created right now. So for this part, what we can do is uh, rename the topic names. Okay, so first from node MCU we need to change the node MCU code, so that we need to send this to feed slash not power to power 1 feed slash current 1. Okay, so we need to do these changes in the Arduino code. So and then what needs to be done is, from Adafruit.io, this platform will subscribe to this topic. It is an internal thing. Okay, so this platform will subscribe to this topic, and it will once it is subscribed, all the data coming to this topic from any other client, node MCU or any third party client like the MQTT box or any other client, we can simply get these data visualized on this dashboard. Fine. So this is the flow of this project, architecture for this project. Okay, so let's see the code, then I will change the code according to this power 1 and current 1 which we have changed in this architecture. Okay, so right now let's jump to our code. So in this code we can see the first is ESP8266 Wi-Fi.h, which we are importing. So this library is important in connecting this node MCU to the Wi-Fi network. Okay, so these are the SSID and password, the credentials to connect to our network. Fine. The sensor in is a variable which is containing A0. A0 is our pin which we are reading. I have already shown you this thing here, that we are using the A0 pin for reading the value of current. Fine. So sensor in millivolt per ampere. Okay, so this is one variable which is very helpful. So it is defined as 66. Why it is defined as 66? Because we are using the 30 ampere variant of our ACS 712 module. So if you are using 20 ampere, you need to change the 66 to 100. Fine. And if you are using 5 ampere, you need to change it to 185. So, and again we have three variables here. Wi-Fi client net, so this is the port number basically. MQTT client, making a object of this class, so we can do the MQTT, all the MQTT stuff using this. Okay, so connect method, we will come to this later. First, this sketch will start from the setup method. Message received is also there, but this sketch will start from the setup method, and then after loop will be executed repeatedly. Okay, so in the setup method we can see that the first line is the serial.begin, so which will basically help us in debugging this thing, so that we can see everything in serial monitor in here. Okay, so it is set as 115200, which is the baud rate. So then we are connecting using the SSID and password which we have defined above. Okay, let me see. Okay, so Wi-Fi.begin, this will connect to us to the internet. Okay, so you can see that this is the connect method. We haven't called it yet, but Wi-Fi.begin, which we have initialized this till here, and then after we have initialized the A0 pin as the input pin. Then after we have used the MQTT client, which is this client object, and begin using these two parameters. This is the broker address. Okay, and this is the net, which is 1883 by default. Fine. And client on message, this is a callback function, message received, which will be called once we have received any message on this client. Okay, on this broker, basically when we receive a subscribed topic, and this will not much importance here, because we are not receiving anything on this node MCU. We are just sending these current data and power data to our Adafruit. So this is contained, we can ignore this part of code. Okay, so at last we have this connect method, and now we need to see that what it is doing. So in the connect method, we can see first we are checking if we are already connected to a Wi-Fi network. Okay, Wi-Fi.status WL underscore connected. Then if it is not connected, we are going to use, so we have already initialized thing. We have already connected using this part with although we are checking once again. So this part, you may think that why it is checking this thing, but it will be helpful if a disconnection will happen. If a disconnection will happen, then it will be helpful, because in the MQTT network, it might get disconnected. Okay, node MCU might get disconnected, then this thing will again execute this connect method. Fine. So that is why this Wi-Fi connector will be checked first. Then after, then only we can connect to MQTT broker. First we need to connect to our gateway. Okay, first we need to connect to our Wi-Fi network, then only we can connect to our MQTT broker. Fine. So this MQTT is the first part, and this two things you can easily get using the if I will navigate to this outer part. Okay, or so you can see my key option here. So just you need to create this, click on this. Okay, and here we can see we have this IO username and IO key. This is the two things we need. Fine. So these are the two things we need to provide here, and after this it will be getting connected to our MQTT broker, Adafruit MQTT broker. Fine. So then we are subscribing these two topics, which is not much important here in the use case, but it is very important in exception handling type of things. Fine. So these two topics, which we are just if we get any message on these two topics, we are just subscribing it so that we can get messages on these two topics. So for errors, for any kind of error at the adafruit.io end, we will get those error on this topic. And how we are getting this? Using this function, message received function. And you can see that it is never called from anywhere. This function is never called, but I have already shown you in the setup part that it is a callback function which will be called every time a message is received on the subscribe topic. So these two are the subscribe topic, and every time a message is received, it will be just printing. We are just printing the message. We can do all other various things like we can do exception handling here, but for these two things we are just printing the topic, incoming topic, and the payload, which is the message. Fine. So this is the setup part, and now we are going to use see the loop part. And here we can see the first thing is client.loop. Fine. So, and a 5 second of delay, which will fix some issues with Wi-Fi stability. If there is any issue in this part, it will be stabilized using this delay. Fine. So client.loop, this will basically, this client is the MQTT client part, and it will we are executing the loop method of it. Okay. And the second thing is, if the client some mishappening occurs, and if this client disconnects, then we are making the connection again using the connect method which we have defined above. Fine. And we are publishing a message roughly every 6 seconds. Fine. Although we have this, you can see this is 10,000, which is 10,000 millisecond is 10 seconds, but we already know that if you have followed my tutorials, we have already know that this thing is not very much accurate. Okay. So millis is a method, and last millis is another variable which we have defined. Fine. So using these two variables, millis gives us the current time which is passed from when the microcontroller is turned on. Okay. So these two methods we are using to get the get the duration delay. Fine. So duration delay we can use, although use the delay method, but that will stop the execution of other part of code. Okay. So delay method is not a good choice here, so we have used the millis and applied this method. Fine. So now the main part comes, and now what we are going to do is we are using this voltage variable to get the data coming from get VPP method. Fine. So get VPP is basically help us in getting the peak current, peak voltage. Okay. So peak voltage we are getting using the get VPP. Okay. So these are the things which we are doing here. So you can see value read from the sensor, read value, and store max, store min 01024. This is the difference. Okay. So this is the voltage difference, basically 1024. As we already know, in the node MCU, the analog pin, we have this distribution as 0 to 1024. Okay. So it is basically 10-bit analog ADC. And the second thing what we are doing is sampling for only 1 second. Fine. So we are making this reading this data, and we are getting this result, which is basically the peak voltage VPP. And after this we are getting the VRMS using the this square root 1 by 2 root 2 into voltage. Okay, so these are the formulas which basically in backend it is basically, if you have seen in the electronics part P, it is a sinusoidal wave, okay, sine wave. And we are just getting from the total V max V peak value, we are getting the VRMS value. Okay, so 1 by 2 root 2 of voltage. Okay, and amp RMS, we are getting the ampere using from voltage. What we are doing is using the millivolt ampere, millivolt per ampere thing. This is the thing which we have defined above, which is 66. Okay, in our case, because we have 30 amp of variant ACS 712. Okay, so what we are doing is first converting this finishing this milli part using by multiplying 1000, it is now voltage. Okay, and voltage will be cancelled, and voltage from voltage, and the ampere will remain, and this is the ampere RMS. And what is this minus 0.12? So this minus 0.12 is the thing which you need to do for the configuration part. Okay, so I need to do in the demo you have already seen that we are not getting the correct value. So how do you get the correct value? So you need to subtract some value or add some value to reach the correctness, to reach the correctness. Okay, so when there is no load, you need to make the current as 0. So add or subtract something here so that the value will become appropriate. Okay, so let me remove this statement, and now we have wattage, basically the power watt, and just simply multiplying the power, which is in my house it is 220 volt. Okay, and multiplying with the current. Okay, V into I, basically I RMS. Okay, and using that we are going to get this voltage, and this is the basically the current, and this second one is the power. Okay, so power and current, we don't need this voltage part. Okay, because it is voltage RMS and we are not showing it in the dashboard also. So the changes which I am talking about was this power 1 and current 1. Fine, so this is the change I have done, and now what I need to do is upload this code. Fine, so what, okay, let me pause this. So the code is uploaded. Okay, so let me turn on the hardware setup now, so you can see the hardware setup power. And now here we have our dashboard. Unexpected error, saving data on feeds current validation, feed limit reached, please remove one of your feeds prior to create a new feed. Okay, no problem. So now what I have done is I have deleted the feeds from here. Okay, by selecting it we will get that option. Okay, in the feeds tab. Fine, so after this once I have deleted it, it is automatically created two feeds. Okay, since we are sending the data, pushing the data regularly if every 6 seconds, so it's just created here, and we can see this recorded value and last value 0.14 for power is this thing. Fine, so these are two things which I have created. So the thing it is saying is power 1 validation unique should be unique. Okay, so current 1 power 1. Fine, so let me refresh this page. Okay, so we are done from that part. Okay, so test is our dashboard, which now what we can do is create a new block of gauge, and current one is our data which is shown by that gauge. Fine, so current can have maximum value, let's say 5 or 30 ampere max to max. Let me 30. Fine, test value we can see 0. Okay, and decimal places which can be shown is 2, and click on create block. So 0.04 is the value received at 9:08:48 p.m. Okay, so this is the first block, and the second block is the line chart. Okay, so here is our line chart, and we are going to use power data to show on that line chart. Fine. So last 24 hours. Okay, so let's say we need to just use the live. Okay, and for 1 hour is also gives a better view. Fine. So that's it. And you can also set the y-axis minimum maximum, fine, according to your use case. But this is the power. If you want to define it, title here. So creating another block, and since it is created below this, if you want to move beside this, you need to edit the layout and move it beside this. Okay, and also you can change, like go to this cog icon. Okay, and edit this block and give it a title, since I have missed it. So let me see, say it is current. Okay, and update this block, so we can see current, power, and save layout. So that's how we have used these data to show on this widget. So this is the gauge widget, this is the line chart. I can't see any data till now, so what I need to do is edit this widget to show the let me see, I edit this widget to basically to show the live data. Fine, and now we need to save this. So this is how our project is working here. Okay, so yeah, you can see a line here. Perfect. And right now this light bulb is in off state. If I turn on this, these values should suddenly increase. Fine, so it is right now 31, around 31. Okay, so if I turn this on, uh, you can see 0.22, and this value from 2031 it goes up to 48. So that's all for this video. You can find the circuit diagram and code in the description of this video. Please like, share and subscribe for more videos like this. Or if you have any idea, join us to collaborate. Or if you want to develop any IoT based project, please contact us. Thank you.